So in this session we are going to talk about VLAN Trunking Protocol or VTP. Let's see what is VTP. What is VTP? It is a layer 2 Cisco proprietary protocol used for synchronizing VLAN creation between switches. Now we will not call it a protocol, but we will call it as let's say a technology, because it's not really a protocol. It synchronizes VLAN creation and simplifies the management of VLANs between two switches or multiple switches. There are three modes of operation for VTP. One is the VTP server mode, one is the client mode, and one is the transparent mode. And by default, all the Cisco switches are in server mode. We can also change the mode by making it either client or transparent. So let's see what is VTP server mode. VTP server mode. In VTP server mode, we can create and delete VLANs. So we have seen about creation and deletion of VLANs in our previous lecture. Now here we will come across some terms like advertisement. Now what is VLAN advertisement? So we will see about these terms later in our lectures. So for this lecture, for the introduction purpose, just know that server mode actually initiates advertisements. It can install VLANs from other advertisements. So if there is a switch which is on server mode, is connected to another switch which is also on server mode, it can send VTP updates, okay, and it can receive updates. This switch, it can receive updates and it can send updates. So if these switches are on server mode, you can create, delete and install, create and delete VLANs and install other advertisements. Installing other advertisements means these VTP updates that we get from the other switches. It has to be a server switch, because in client mode you cannot create or delete, which we'll see right now. So VTP client mode, we cannot create, we cannot delete. It can only advertise VLANs. So if we cannot create and delete VLANs, and it has to and it can advertise VLANs, so that means that it has to come from another switch which is on server mode. So because we cannot create or delete VLANs in client mode. So yes, this one is the prime difference between the two, between server and client mode. It can advertise VLANs, it can install VLANs from other advertisements. These two features are same, but this one is different. This is the we can say tiebreaker. So this was about VTP client mode and VTP transparent mode. So earlier we saw in VLAN that in VTP server mode we can create VLANs that ranges from 1 to 1005, or to be specific 2 to 1001, because 1002 to 1005 were FDDI and token ring. So in server mode the creation of VLAN will range from 2 to 1001, and whereas in the VTP transparent mode we saw that extended VLANs, I mean from 1006, okay, 1006 to 4094 in VTP transparent mode. So let's see what is VTP transparent mode. VTP transparent mode creates locally significant VLANs. It creates locally significant VLANs. Locally significant VLANs mean that we cannot create or delete VLANs from, if we are in a transparent mode, we can create it, but um, the creation will be locally. I mean to say, suppose if there is a switch in server mode, there is a switch in transparent mode, and there is a switch in client mode. Okay, so if a VLAN is created here, suppose VLAN 10 is created and it sends an update to transparent mode, it will not install VLANs from other advertisements. So it will not install the VLAN 10 over here. Whereas if this was a client mode switch, and if the server switch sends an update to the client switch containing VLAN 20, let's say this switch will install it, because we have seen that, let me show, okay, VTP client, we have seen that it does install VLANs from other advertisements in client mode, but in transparent mode it will not install VLANs from other advertisements. However, it will forward other VTP advertisements. So the transparent switch will not have VLAN 10 over here, okay, it will just forward it to the client mode. The client mode, client switch will have VLAN 10 because it can install advertisement from other switches. But the transparent mode switch will not have the VLAN 10 because it does not install VLANs from other advertisements. It will have VLAN 10 only when we manually configure VLAN 10 over here. We manually do it, okay. So it will not install the VLANs forwarded from the other switches, but it will but it will have those VLANs which have been created over here manually. But VTP server and client mode, they can install advertisements. We need not configure any VLANs over there statically or manually. It will automatically keep on installing whenever it will get an update, okay. So this was the introduction video, and let's revise it for a bit. So by default all the switches are in VTP server mode. So suppose when we configure VLAN 10 in the server mode switch, okay, and it generates a VTP update. VTP update should be like the data and the VLAN tag, the VLAN ID tag 10. So like we discussed in VLAN, the access and trunk ports carrying the data, the trunk port carrying the data with the VLAN tag. So these will be the updates. That was the update packet. So like when we configure VLAN 10 in the server mode switch, it would generate a VTP update and then shares the and then it would share the info to the client switches. This advertises the VLAN, okay. Now let's see a scenario over here. Okay. I need to delete these. So let's take okay. This is a server mode switch and this is a client mode switch. So in between these two it will be a trunk trunk link. Okay, and suppose this is a fast Ethernet 0/0, and we have it's an access port, and we have configured VLAN 10 over here. Okay, so we need not go to the client switch and configure VLAN 10 over there also, because it will automatically this VLAN will automatically be advertised uh, over the trunk link, and it will be forwarded to the client switch. Okay, but it would not happen in case if it's a transparent switch, because transparent switch do not install the updates. It will have the VLAN if we configure it manually. So these are the differences between the three modes of operation. So now let's configure something, configure the three modes, and let's see what happens. Okay, now I have a topology over here. This is one, this is switch is connected to another switch, and the end users are here. Okay, now what we will do over here is we will configure these as access ports, and these this as a trunk port, like we did in a access and trunk port trunking video. And then I'll be creating a VLAN, then we'll be setting a VTP mode and VTP domain name. Now I'll now VTP domain name has to match. If we are configuring a topology over anywhere, if there are 5 switches, or let's say n switches, they have to have the same VTP domain name. Otherwise, if the domain mismatches, then there would be no advertisement, and then there would be mismatch. So VTP domain name should be matching. Okay, so let me configure. Interface FA 0/2. Maybe to configure first trunk port 0/2. I'd be making it dynamic desirable. Then I'll be configuring the mode. So by default it's always in server mode. So we will still, let's see, yes, client, server, and transparent. Set the device to client mode, set the device to server mode, and set the device to transparent mode. So we will do it, set the device to server mode. Okay, device mode already VTP server. This shows that by default every switch is in VTP server mode. So now we have to set a domain name, VTP domain, say Cisco. Okay, set VTP domain name from null to Cisco. So in by default every the domain name is null, and when we change the domain name, it's changed from null to whatever we are setting it. Okay, now I'll be creating a VLAN. Say VLAN 10, name IT, VLAN to 2 end devices, so yeah, to name sales. These are not case sensitive. The VTP domain name and the VLAN name, they are not case sensitive. But Unity have uniform, like if I'm giving it as all in caps, so I'd like to have these also in caps, these names also in caps. So it's up to you, it's your choice. So now I have created VLAN over here. Okay, so if I go to switch 2 and make it a client mode, by default I'll have these two VLANs, I mean VLAN 20 and VLAN 10 and 20. So let's set this to client mode. VTP domain Cisco, already set to Cisco, yes. VTP mode client, setting device to VTP client mode. Okay, now our job is to verify whether what we have learned in what we have seen for now is correct or not. I'll go to switch 2 over here, that's switch 1 already. I'll see the trunk interfaces first. So we see that if a 0/2 is running in desirable mode, dynamic desirable mode, it's trunking, and native VLAN is 1. We all know that because I have not set any VLANs in for a particular port. VLANs around or trunk 1 to 1005, port FA0/2, VLANs around and active in management 1, 10 and 20, 1, 10 and 20. 10 and 20 we have created, and 1 is the native VLAN. These are the VLANs available. Okay, for now these are the VLANs available. Now we should go to switch 2 and see the same. Okay, show interfaces trunk. So by default dynamic auto, we know that. Now we will verify VTP configuration, okay, by using the command VTP show VTP status. So let's go back to switch to show VTP status. Now see carefully over here, VTP version is 2, maximum VLAN supported locally is 255, number of existing VLANs 7, server mode Cisco, and these are some details we will not look at right now. And now we should see the same for the switch in the client mode. Show VTP status. It's in client mode. Configuration revision number 4. Configuration revision number 4. So everything matches because this was a server switch and this was a client switch. There was no need. See, I did not create VLAN 10 and VLAN 20 over here, but still we are getting VLAN 10 and 20 over here. So this means that whatever we have learned till now, the theory part is supported with the practical part. Okay, so this was all about the introduction, and the next video will be on the working of VTP, and then an extensive lab. So this was it.